Hello everybody, my name is Elnor. I'm from the Petroleum Engineering Department, and this lab name will be Center of Pressure for Fluid Mechanics class. So let's move to the table of content. There will be introduction and theory, objectives and methodology, experimental setup, results and discussion and conclusion. As for the introduction, what is pressure? Pressure is a force applied perpendicular to the surface of an object per unit area over which that force is distributed. Pressure is also called absolute pressure. But we are here interested in hydrostatic pressure, which is the pressure exerted by a fluid at rest due to the weight of the fluid above the surface. So to find the hydrostatic pressure, the formula is rho gh. Rho is the density and h is the height of the fluid. So here are some formulas, but since the time is quite low, I'll pass them. So the main thing here is the equilibrium condition. So to find the center of pressure, we need moments and the equilibrium forces and moments. Here, the F multiplied by H double prime is equal to VW multiplied by L. So W here is the weight applied to the hanger, and length is the length of the arm from the weight to the center of pivot, center of balance also. So H double prime here is the second moment of inertia, also the center of pressure. So actually we are looking for H double prime here. So in the very end, the formula is given H double prime is equal to H prime plus H negative D. So we'll use that formula to find the thing, and our objectives are to determine the line of action of thrust and to compare it with theoretical results. So as for the methodology, first we take a unit frame is placed at the height that allows access to supply water. Then we drain the point to flow into a convenient drain. Secondly, we put a level indicator on the base to help ensure the unit is level. Thirdly, the balance was fixed to the quadrant. Fourth, by winding up and down the threaded portion of the arm until the quadrant is sitting level in the tank. 5. Assuming the drain valve is closed, the unit was filled with water. 6. One of the 0.1 Newton supplied masses was added to the mass hanger. Then water was added into the top of the tank until the level marking on the quadrant lines up with the top of the tank once more. 7. The immersion depth on the scale on the side of the quadrant was recorded, and some measures was taken to get an accurate reading. And at 8, step 6 and 7 was repeated until the water level just passes over the top of the vertical quadrant face. Then we repeated everything, coming back down, reducing the hanging mass of the weight. As for the apparatus, we had center of pressure apparatus, which looks like that. Actually, this is already the whole thing. We have the center of pressure apparatus, plus you see this hanger and weights. So we have the meter rule to calculate the meterings, and we have hangers and masses, which looks like this on the previous picture, as can be seen here. And here are our results and discussions. So some of the data is given previous hand, like B, D, H, and L. And these are the experiment results that we use different methods. Each time we add 0.1 Newton, and the depth is increasing, as you can see. So these are the calculations all done and ready results. So this is theoretical results of center of pressure, and here is the real experimental results. So as you can see, they are quite similar, not quite far from each other. And here are some sample calculations, how we find H double prime. Using that formulas and theoretical values, we find the experimental and theoretical ones. And then we extract H double prime, D, and F to plot our data. So as you can see, this is the force versus the center of pressure and the depth of immersion. and our graph have some inc inconsistency here. It's because it's experimental and there can be some kind of errors here, but however when the thing goes up, it goes quite well. As for the results obtained in the experiment, it showed a great small difference between theoretical and experimental values. However, the experimental was a bit greater. There were some errors, of course, but this may be due to parallax error, or it may happen due to when the pouring water. I may not touch all of them because the time is limited. Other than that, the error may be due to the instrument, also the surrounding. And as for the conclusion from the experiment, we can conclude that the experiment was successful, even though there was a little difference between theoretical and experimental value. From the graph, we can clearly depict that there is a linear relationship between hydrostatic force, depth, and center of pressure. So comparing the theoretical experimental center of pressure, the experimental one was greater. This may be due to the parallax error. And since this proved correct, this knowledge can be applied in engineering such as dams, sailboats, airplane, aerodynamics, and missile aerodynamics. This is all for the lab, and thank you so much and have a great day.